Our next speaker is senior engineering manager who leads the cutting-edge projects and guides the talented teams in building innovative software solutions. Today, he will share his insights on one of the most advanced tools for developers and the Microsoft Agent Framework. This session will give you a deeper understanding of how to build intelligent agent-based applications using the Microsoft technologies, a key skill for next generation of developers. Please join me in welcoming to stage Mir
Alexander Trofimenko. Thank you.
Hi everyone. First of all, thank you to all of you who joined today's conference. It's really glad to see so many people, and of course, thank you to people who organizes such a cool event, make it real. Thank you very much. All right, and yeah, let's move on. Seems it's working. Thank you, guys. All right, yeah, today I will talk about Microsoft Agentic Framework, a new framework for Microsoft. It's released pretty recently, I think roughly a month ago. But yeah, it's like some new generation that we're expecting, and like it should really change the approach how we're currently building agentic solutions and so on. Before we start, yeah, my name is Alexander Trofimenko. I'm working in a EPAM company as a senior engineering manager. I am a certified solution architect in Azure. Yeah, and of course, I also ambassador inside of my company, so it means that like I'm trying to spread out the knowledge about AI, how it can be used in real projects, where we can use it, and where we need to avoid this, because to be honest, AI hype, it's cool, but we need to be meaningful about where we can embed it, where we can embed this cool tool. All right, and agenda. So yeah, firstly, we will try to understand what does it mean in general, agent, because it's everywhere right now, agentic framework, agentic AI, SDLC, agentic mode, and so on. So many such buzzwords, but yeah, need to understand what does it mean agent and why it's in general we created such thing. Wait a second, please. Can you please go back, guys? Yeah, to agenda, but all right. Cool. So yeah, also we'll go for about new foundation, why it's happening. We also review what was before, what introduced in this new Microsoft Agentic Framework, why it's needed, what is the benefits of using this comparing to previous approaches. We'll see which pillars is embedded in this framework and some patterns that we can use when we create new applications using different agents. And yeah, we'll see how we can build, integrate in which machines, in clouds, and so on. And of course, I will show some already a real case from production, big companies who use it and implement it successfully or continue implementing some solution using this framework. All right, what is the agent? As you see in the middle, it's like a heart of any agents. Of course, it's like some high-level understanding what does the agent mean. It's LLM, large language model, instructions and tools. Three main components. So LLM to, in general, operate with any interactions. Instructions, we can specify how exactly we need to interact and with inputs and outputs and so on. And some external tools that will help us to get more knowledge, make some actions and so on. So, and yeah, tools, as you see, like we can, using tools, retrieve any information, find in, I know, vector database, get knowledge from our local storage. Also, we can make any actions, call MCP, A2A protocols, classical REST, so any actions that we can do. And of course, we have like a memory. Memory can be stored in different ways, but its main point is that like what agent is doing, it's like memorized. And yeah, workflow. So in the input, we have like a different input formats. So it can be system event. So something happened in system, we notifying using event, and we need to somehow manage this. As well as like user messages when we have like a multi-agent platform and we're receiving some input from a user that we need to do something like this. And of course, in a multi-agent system, we have like an input and output messages from different agents, because in such system, agents should communicate each other in different ways. I will try to show how exactly. And yeah, in output, we also have like a tools results that we can provide to another agents or to user as our some finished result. All right, so we see agent. It's like created for such reasons. Let's see what is the difference comparing to some classical approach, because before we had like some robot automation processes, so different approaches, how we can automate the workflows, user operations, so some routine tasks and so on. Comparing to previous classic approaches, agent has three main benefits. It's like a reasoning, as you know, like some right now a lot of LLM models already have built-in reasoning, so we call it reasoning models. It can understand what is going on, maybe iterate the logic and so on. As well as like an agent can act using the LLM and using different tools. And of course, as we previously mentioned, that it can learn. Learn means like if something done, it can be memorized, which exactly was successful, what failed, and so on. So this is like some sort of self-learning system. All right. So three main benefits using the agent. But what was before? Before we had like some way of robotic automation approach when we like need to see specific actions that will be done. We record them using UI or specific scripts and try to automate them, just like play these actions in some environment. And yeah, we like faced with many issues, especially of data, because in most of cases in real production we have like raw data. It's unstructured, not well defined, a lot of noise in the data, and so on. And of course, using such type of data, it's like it was impossible to implement the strict workflow to do it in the right way. So before we start any automation, we needed to clean up the data and structure this, and we spent a lot of time. With LLMs, of course, if data is clean, it's better. But again, LLM can understand what exactly in the data, and it's not like our understanding how we see the data. Yeah, instability of previous approach. Robotics, it's time to time can fail, and it's just like a failed with some error. After that, we need to spend some time to understand and debug it, why it's happened. And if something changed on screens or in web interface, it will be broken. So it's strictly for specific UI elements or in web UI or in operating system UI and so on. And yeah, last part, it's like it's predefined flow without any knowledge how to interact if system will fail. What we can do as maximum is like put some retry logic. For example, if like, okay, if you failed, wait for some time and try one more time, and that's it. It's no like some understanding how it can be done in another way. It's all classical approach. That's why like we, of course, need new foundation. And some frameworks already appeared. Besides this Microsoft Agent framework, most probably you heard about another frameworks in which we are capable to build multi-agent systems, but most of them it's like in some research and non-production ready state. That's why like we saw some difficult and issues with current state of most of the frameworks, not of all, but most of them. It's fragmented frameworks. It means like to build full operation system for multi-agent solution, we need to combine different frameworks. Write some code to combine this, I don't know, some sort of operations. So anyway, like if you want to build full solution, we need to combine different frameworks. And different frameworks supporting by different teams, different versions, and it leads to specific problems when something is broken and we need to fix specific part of this solution. Research versus production gap. So most of the stable frameworks, like for example, semantic kernel, they're pretty well defined and focused on production. So there is no any new cool functionalities that are unstable. And there's no any opportunity to put something as a POC, research, and try it out in your application. Third point, it's like a slow iteration from local to production. So very popular issue that we're trying to build something on our local machine, it's working fine, then we try to deploy it to our on-prem server or in cloud, and he is going on I know, a lot of issues, connection issues, or different IP standards, and so on, and it's broken. And we need to spend a lot of time to stabilize it. And reiterate one more time, when we fix it locally, we try to put it in production, in the cloud, and it's broken. Yeah. All right, next one, limited extensibility and closed systems. It means that most of the frameworks, they are handled by specific teams. In most of cases, they are private one, closed. It means like you cannot affect on this framework. You cannot like extend it by your code or propose any enhancement. And last one, it's enterprise readiness. A lot of frameworks, as I mentioned, they are like for researching for POCs. So they are not like ready for production where we need to solid governance, logging, monitoring, all the stuff that are really important for big companies, for enterprise level. In most of cases, they are missing. And that's why like this new framework, Microsoft Agentic Framework, is appearing. It's not super new thing. It's like a combination of already two existing frameworks that also provided by Microsoft. One of this, it's like a semantic kernel. Ildar already mentioned this one. It's pretty well defined standard. It's production ready. But of course, there is no room for extensions, for new features, and so on. But all these like capabilities we have in another framework that's after Gen, also supported by Microsoft, by specific team, and this focus for research operation for new agents that can be easily introduced and embedded in an already production-ready system. And yeah, if you combine these two frameworks in some unified thing, it's like our new framework that's called Microsoft Agent, but under the hood, it's like a just unification of two already existing frameworks. All right, main concepts, main pillars of this framework, because why we really need this and what we are trying to resolve using this framework. Open standards. Again, standards should be supported by all frameworks that embedded, specifically for after Gen and semantic kernel. So there is like a unification of protocols of standards. Plus, it will be open source, so it's available for everyone. You can extend if you need it. You can create pull requests. You can fix a bug. So, and always you can review the code, what under the hood of this framework. So, this leads us to next main, I think, benefit and pillar is like extensible and community. So, if it's open source, it's available for everyone. Every team, every every developer can contribute to this one, extend it, do any changes that needed, and proceed with it. And community, of course, will support it by many enhancements, features, and so on. All right, the third it's research pipeline. It means like using after Gen inside of Agentic AI. We can embed new technologies, new approaches, and we will be sure that it will not break the current implementation. So it will be stable enough. At the same time, we will be free to embed something new and new functionality. And yeah, it's a strong focus for enterprise ready, for security, compliance, integration with already existing systems like Azure. Yeah, of course, it's from Microsoft, so strong focus to Microsoft Cloud called Azure and all this ecosystem. But besides that, of course, it's open source and we can implement any solution without locking on specific vendor. All right, let's move on. It was about 4 pillars, but what inside? It's like a patterns how all these agents inside of this framework can communicate. And I just want to show like main 5 approaches, main five patterns in which we can operate. First one is like a pretty straightforward, and I think the simplest one. It's like a sequential orchestration. It means that we have some input, and we need to do calls of our agents in a sequential mode, so one by one. Good example is like some sort of tools that provide summarization, translation, and answer your question. It's like our classical chatbot, in which like we receive information from user, try to summarize information. If it needs to translate, then we try to find information in external systems and answer to the question. So very popular, but yeah, the simplest one, I think. Second one is like a concurrent orchestration. It's more applicable for cases when we need to do different operations in parallel. They are not like depend on each other, but result, some like a step of aggregation will be in place. For example, we do some refactoring or building solution, and some agents can do it in parallel. Some agent writing front-end code, another back-end, third one updating documentation or diagrams and so on. And then in the end, it aggregates the result. All right, third pattern, chat orchestration group. What is all about? In this approach, in this pattern, we have like a different agents. Each agent has own role, and we have like some common place where these agents communicate to each other. I would say it's like some sort of simulation. It can be like different departments like marketing, engineering, and so on, or it can be like some team. In this team, we have developers, QA engineers, project manager, and so on. And all they together communicating in a chat. They see like replies to a request, so it's some sort of like a simulation of real small team. And in the end, of course, we're receiving some result. Okay, next one, handoff orchestration. In this pattern, we don't have some core core agent. Each agent like behaving on their own, but each of them knows how to proceed and how possible to hand off the actions to another agent. A real example is like a support multi-agent system in which we have, for example, some general agent which try to help with some issues to our clients. If it's not possible, they need to transfer request to technical part, to product team, or something like this. But each agent knows how to hand over the actions to another agent in the system. Last one, magentic orchestration. It's from after Gen, magentic one pattern. In this way, like we have one main agent which orchestrates and knows about everyone in the system and try to resolve any issues. So in this approach, we know that there is some core agent which is like a God agent. It knows about another agents and orchestrates the work. So is it like 5 patterns? They're different. We can apply in different ways. Of course, it's up to us how we can implement it. All right. Ways how we can integrate and build. Using Microsoft Agent Framework, there's 3 main options. So we can decide how we want to build this. It's provide different levels, so like infrastructure as a service, platform as a service, and like a software as a service. So we can choose. Of course, if you go to the right, we will be more vendor lock. I think it will be more expensive, but we will do less work. But less customization, less control, and so on. On left side, it's like our own code that we can run locally, we can debug locally, sorry, and so on. But in general, Microsoft provides 3 options, and we can choose. So first option from the right side, when we are using full software from Microsoft, Microsoft Agent Framework will be embedded in the system, operate with a Copilot Studio, that it's like a low-code, no-code platform. Plus, it will be connected with all needed integrations, channel communications, you see Slack, Teams, and so on, as well as other models. So in this way, we will not worry about infrastructure at all. We just develop application, most probably without any code, because using Capella Studio, it will be just drag and drop visual diagrams, and that's it. Another option, if you will go just with Azure AI Foundry, another platform that not stick to Copilot Studio, but it's some sort of infrastructure that well-defined and prepared for agentic implementation. Here we have already predefined and established tools. We have actions, as we see, MCP or logic apps, or just call any of your APIs. At the same time, we have our own storages for information. They are deployed to cloud, but it will be on our own. Plus, we already have all needed models that provided by Microsoft Azure, and we can utilize them. It's a cheaper solution than previous one. Here's benefits that infrastructure in one place. We don't need to worry about how we need to deploy and so on. We just focus on implementation. And last approach is when we're using our a code level solution, using the code without any visualization or abstractions. Many benefits of this approach. We do not stick to specific vendor like Microsoft. Of course, Microsoft does not like it, but anyway, it's not good when we stick to specific provider. We can easily port to another platform, or I don't know, deploy on our local machine or on-prem server. We can easily run on our machines. So if you have some small model that we can able to run locally, we can play around, run locally, debug it, trace it, and so on. And yeah, using code-first approach, we have a lot of extensions. We can write our own code, embed in the framework, and proceed with it. So for developers, I think this approach will be more suitable because more customizations. And yeah, let's move on talk about use cases and some sort of success stories. I just put it two of them because it's more well-known enterprise level company. So first one is about BMW. They already embed this framework in their company, and they're using this multi-agent system to aggregate and proceed with all information they're receiving from all vehicles, from all cars in real time. So previously, to combine all this information, receive, accumulate, and then analyze, they took days. Right now, it's it takes hours to combine all information and make a right decision. So it's really speed up all needed process in BMW right now. And Fujitsu, another company that continuing embedding this approach of Microsoft Framework, they using in another way. They built a group chat in which real employees communicate with predefined agents and try to brainstorm, analyze information, and come up with ideas. So it's some sort of transformation of a company when they're trying to embed agents and AI technology smoothly and incorporate with real employees. Besides that, of course, you see a lot of companies already embedded in their system, and I think we'll be continue implementing. But such brands, as you see on the screen, it means it's trusted by them, and Microsoft provide a real good solution that can be applied and applied on enterprise level, and it will be scalable. Sorry. Last part, takeaways. If you're interested in this, you see a QR code on the screen. You can follow the link, scan QR code, and you will see the guide how to start. It's available in two right now languages, C# plus Python. You can easily run some boilerplate, some basic multi-agent framework in, 15 lines of code. So it's really easy to start. And yeah, few takeaways. So Microsoft Agent Framework, what is about? It's about, it's open source projects. It's open for everyone, it's extensible, plus it combines two main platforms like AutoGen plus semantic kernel. Second, it's like operates and like based on four main pillars. That is ready for enterprise, extensible, you can innovate and play with new technologies, plus it's open for everyone. With agent patterns that we reviewed, they are already predefined, but you, of course, can play around with another patterns that will be needed, come up with new ones, but such patterns that we saw already like embedded in this framework. And plus, yeah, latest takeaway, I think biggest benefit of this is possibility to run solution and develop fully locally without sticking to any cloud, supercomputers, and so on. So you can run your local LLM on your laptop, you can debug it, you can implement it, develop, and so on, and then easily transfer to any cloud provider or on your server without any interruptions. All right, that's it today from my side. Really suggest to thank you.